Now we're moving on to the first application for lines, finding the shortest distance between a point and a line. Similarly, this also works for parallel lines. Let's say we have a point A on this line. This is basically the same as finding the shortest distance between the point and line. Just keep that in mind if you see a question on parallel lines. Now, find the shortest distance from this point to this line. We have this point over here, and the line represented by this here. I have my positional vector 5, 1, 5, and my directional vector 3, 2, 1. First off, what I want to do is find a general vector from A to any point on the line. So to find this general vector between A and any point on this line here, what I'm gonna do is take A minus this line. And what I should get is negative 2 minus 3 lambda, negative 1 minus 2 lambda, and negative 6 minus lambda. Now the rationale behind this is similar to why we take AB equals to OB minus OA. Now let's say we have this vector here. Okay, it doesn't really matter the direction of the vector. What we want to do is note when this is 90 degrees. When this is 90 degrees to the line, this length over here is actually the shortest possible distance. All the other distances are longer. I'll call this point over here F, the foot of the perpendicular. So what I want to do is have this general vector be perpendicular to specifically the directional vector of the line. Yes, it's kind of perpendicular to the line, but more specifically, the vector that this is perpendicular to is vector 3, 2, 1, which is the directional vector of the line. And remember the very important result, A dot B will be equal to 0 if A and B are perpendicular. So we have this general vector over here, and if we dot it with the directional vector, this should give us 0 for a specific value of lambda. What's this trying to say? We have all these vectors, we are trying to find the specific value of lambda where this is perpendicular. And hence, for one specific value of lambda, there's this work, and this is finding our vector AF or FA. So if we evaluate the dot product and do our algebraic manipulation, what we should get is lambda equals to negative 1. Now remember our question was to find the shortest distance, so what we want to find is this distance FA. To find vector FA, actually doesn't matter if we find vector FA or vector AF, because what we're trying to do is find the length of this vector, which will be the same even if it's AF or FA. So we just substitute lambda into this general vector up here, because we know that when lambda equals to negative 1, this is referring to this vector over here. So after we substitute lambda equals to negative 1 into this, we get vector FA to be 1, 1, negative 5. And now the last step is to find the magnitude or the length of FA. And this is just 1 square plus 1 square plus negative 5 square. Simplifying, we get 3 root 3 units. And that's this length over here. And that answers the question. That's the shortest distance. The second application is finding the angle between two lines. So this question states, find the acute angle between this line over here and this line over here. This formula, if you look at this properly, is just the dot product formula. This is not given in your formula booklet, but it can be very easily derived from your dot product formula. Again, when it comes to finding the angle between two lines, we are not taking these two as the vectors. The vectors that we're taking over here and over here are your directional vectors, which is this and this. This is because we are finding the angle between these two directional vectors over here. These two over here represent a position vector from point O. So we cannot use the equation of the line for this, just the directional vector. Let's do this. Cosine theta equals to mod d1 dot d2. That's just the two directional vectors dotted. So let's do that. Negative 4, 1, 2 dot with 1, 2, 1. And this modular sign over here is slightly different from the normal dot product formula, but I just have it there just so that this will always return an acute angle. And we have this over the magnitude of the first directional vector times the magnitude of the second directional vector. Let's evaluate this dot product over here first. This is just negative 4 plus 2 plus 2. Oh wait, that's equals to 0. So we know that cosine theta will be equals to 0. And hence, theta will be cosine inverse 0, which we know this as 90 degrees. So now we know that these two lines are perpendicular. Actually, right, the two lines don't even have to intersect for us to find an angle between them. Because we are looking from the top-down perspective, we are still finding the angle 90 degrees between the two directional vectors. The final application for lines will be the relationship between any two lines. As I've kind of alluded on earlier, we can have lines that do not intersect, even if they're not parallel. That's what we have here, non-parallel and do not intersect. This is what we call skew lines. Before we cover that, let's look at some of the other lines. If they are parallel and intersecting, this just means that they are the same line, and that is coincidental lines. If they are parallel and do not intersect, this means that they're just parallel and separate. Now, if they're non-parallel and intersecting, it just means they are intersecting. Here I have a green star over these two because intersecting and skew are the most important two. And for skew lines, this means that they are non-parallel and do not intersect. So how does that work? What you can think of is these two vectors are on parallel planes. So these are two planes, and these planes do not intersect at all. They are parallel to each other. What planes are just 2D. So you can take like two A4 papers over here and over here, and these two A4 papers will be parallel. That is what we can visualize as parallel planes. Now if we take any one vector on this plane and another vector on the other plane, as long as they are non-parallel vectors, they are skew. Now just to remind you, parallel vectors means P equals to KQ, where P and Q are the two directional vectors of the line. So if this is true, and again, K is just any constant, this means that the lines are parallel. Non-parallel just means the opposite, where this is not true. Now intersecting means that there's a consistent parameter. If you look down here at the question, this means that the two parameters, alpha and beta, are consistent. There's a consistent value of alpha and beta throughout all these three equations. And now, the lines do not intersect if the parameter is not consistent. Now let's actually try the question. Determine if the following lines are skew. We have two lines over here with two parameters alpha and beta. So what I want to do is first find out if the lines are parallel. So let's look at the directional vectors. The directional vector here is just 3, -1, 2. You can convert the line into a vector form if it helps you to see better. And now we have the second line, the directional vector is 2, -1, 1. And we can see that this is not true. Hence, the lines are non-parallel, so it's one of these two. Now, to show skew lines, we not just have to show non-parallel, but they also do not intersect. So let's see if they intersect or not. Now, we want to find whether the parameter is consistent or not. How do we find out if there's a consistent parameter? I will equate first the x's together. So -2 plus 3 alpha equals to 1 plus 2 beta. And I'll equate the y. 3 minus alpha equals to 2 minus beta. And if I solve the simultaneous equation correctly, I should get alpha equals to 1 and beta equals to 0. So now, to check if the parameter is consistent or not, we're going to substitute this into the z. So we have 1 plus 2 times alpha, and let's see, is this equals to 3 plus beta? Yes, this is true. Hence, alpha equals to 1 and beta equals to 0 is a consistent parameter over here. That means there's a value of x, y, and z that are the same. And this value of x, y, z that are the same is just this point over here where the lines intersect. So actually, this is intersecting and not skew. If you want to find the point of intersection, you can just substitute alpha or beta equals to 0 into over here. But we've answered the question. Since the lines intersect, they are not skew. Here's the summary sheet for just lines. Thank you so much for watching, and I hope you've learned a lot from this video.